This video presents an introduction to the modeling concept of the Topology as a Service framework and an interactive demonstration of some features based on sample implementations. Topology modeling is really the basis for all services within TaaS. In fact, every service operates on a given topology model. Modeling in TaaS is easy and comprehensive. It encompasses features for all the infrastructure and software deployment needs of entire applications. Users, typically application developers, but also system or product engineers, can express their intent from their high-level point of view without having to specify proprietary product details. In a typical process, topology model templates are specified first by building them up using a catalog of reusable third-party or in-house created parts. Later, these templates are instantiated, managed, and deleted again any number of times and under varying circumstances. True portability is achieved by avoiding environment, product and version-specific details in the models. Within the system, topology specifications are text-based. Currently, JSON is used, but YAML or other formats could easily be added. For human users, however, it is much easier to construct topologies interactively with a sophisticated direct manipulation graphical user interface that is included in the TaaS framework. The topology specification language is carefully designed. It is declarative, strongly typed, and based on proper grammar. In essence, two major constructs, nodes and connections, are supported, both in just a few variations. Nodes are the building blocks of topologies. They can be compute nodes as parts of infrastructure specifications, or deployment units in deployment specifications. A compute node has one of three types. A basic node is an opaque building block whose inner details are not further modeled, representing, for example, an operating system within a virtual machine or a network load balancer. The other two types are used to build up structures of nodes, be it vertical stacks, so-called layered nodes, or horizontal layouts, so-called topology nodes, meaning topologies represented in a single node. On the other hand, connections specify relations between nodes. We distinguish three types of connections. Communication paths represent communication protocols that can be used by applications to call from one node to another. Infrastructure dependencies specify infrastructure-related semantics between nodes, for example, that they should never be instantiated on the same hardware server. And finally, software distribution flows connect deployment units to compute nodes on which they must be installed. The TaaS framework understands the rich, high-level semantics of the topology models and is able to derive important information for services. For example, ordering of operation steps in hierarchical layers, node placement constraints on hardware or data centers, expressed as affinities or anti-affinities, or synchronization points in parallelized orchestrations, for example, when scaling tiers. So what we see here is the graphical user interface of the Topology as a Service portal. We see the catalogs of reusable parts that can be used to construct topologies. And we see the area of canvases that can be used to edit or display and inspect topologies. And finally, the CMDB with the uploaded topology templates or the constructed topology instances. To begin with, we just construct a simple example of a topology to see the basic functionality. We can drag in nodes from the nodes catalog, in this case from the Java Enterprise layer. We selected a WebLogic 12 web tier node, which is a layered node with properties. Properties are the typical ones, an ID and the name, but also it contains the realm that was created to customize the topology as a service framework for the Java Enterprise realm. From the realm, we also say what kind of connection types these nodes can accept. Application connection types, meaning connecting nodes in the applications, can be HTTPS, REST, and whatever, as well as outgoing connection types. We could use REST instead of calling out to EJB. We have infrastructure connection types as the second way to construct connections. Here we only have bidirectional types for horizontal scaling, server anti-affinity, or whatever you want, data center affinity, for example. And finally, the third type of connections that we can accept in these nodes are software distribution connection types. In this case, because it's Java Enterprise, we can send Java Enterprise WAR files, jar files, or EAR files to such a node. Finally, the provisioning properties are displayed. This kind of node can be constructed by cloning a virtual machine template. It has a source name and a version for that template. In addition, we have custom properties that in this case typically are log file paths of files that are created in the target node that need to be logged and shipped to a central log management facility. Ports are specified and so on. In this case, we actually talk about a layered node. That's a WebLogic server. In this case, could be any other Java Enterprise standard product that is laid on top of an operating system. So if we drill down, we see what's below it or inside of the node. In this case, a Red Hat Enterprise Linux 7 virtual machine. If you look at these properties, we see the properties that have been created by the OS realm that customizes the framework for the Red Hat Enterprise Linux 7. Again, we have the infrastructure connection types. In this case, the software distribution is just RPMs that we chose, and again, it can be cloned from a VM template. This is already a final, possibly useful topology that we could now give a name and then upload to the CMDB in order to use it. But instead of doing that, we delete it again and create a new one that is then slightly more complicated. So for that, we drag in an entire elastic tier from the Java Enterprise realm, in this case WebLogic server, and if we look inside of that, we see that inside of the elastic topology node, in this case, we see the layered node from before. That's a WebLogic server web node on top of the Red Hat Enterprise Linux 7 VM. In addition to just showing what's inside, we can also see that the connections are wired up. In this case, it means the incoming connection to the topology node, to the encompassing topology node, is wired and leading to the inner layered node, the WebLogic server. Outgoing connection, similarly, what's coming out of the WebLogic server is going out to the topology node. In this case, for example, a JDBC connection, and the other way around for the software deployment connections. A near file that is deployed to the topology node outside will be relayed to the inner node. In this case, it's only one inner node, because we are only constructing templates of topologies. Once we provision such a template or instantiate such a template, then we are able to say how many inner nodes we want, or the range of the number of inner nodes that we want, and then this single template node will be replicated as many times as we choose. Because this is a scalable tier, we also want typically to have a load balancer in front of it. Maybe even a highly available setup. In this case, we just choose a single load balancer. Look at its properties that are coming from the network realm that customizes this node to contain a particular load balancer. Again, with certain connection types, let's choose HTTPS for our Java Enterprise tier connection. It's a shared hosting system in this case, so it's not something that gets provisioned entirely, but on an existing load balancer, when we provision, we allocate a virtual server on top of it. So if we save that, we can actually connect the load balancer to the Java Enterprise tier, because we only have one connection type enabled, HTTPS. That's what's chosen directly. Otherwise, we could go and actually change the actual type that is allowed. So this is a full-fledged topology that is actually useful, can do something. So let's give it a name. In this case, maybe something like Demo1, and upload it to the CMDB. Of course, you need to have the rights to do that. You also need to specify typically on behalf of which application you are doing that. We just have a very simple scheme where the applications are numbered, and we can say upload. Given that we have the rights to do that, the Demo1 is actually showing up in the CMDB. So let's get rid of our construction canvas and look at the Demo1 example in the CMDB. So we could provision it, we will look at that later, but just open it and we see it's exactly the same layout. We could drill down, it has the same properties. It's the same thing, but because it's uploaded to the CMDB, now we can start working with it. Before we do that, let's look at the possibility to serialize the description of that topology, and that's actually also how it's stored in the CMDB. We could actually look at the visual layout or just the raw content. So we download a file containing the description as it is stored in the CMDB, which in this case is just JSON, could also be something else like YAML or whatever we choose to generate. So this is a full-fledged topology that can be provisioned, looked at, and deleted again. As an example of how topologies can be modeled and entered into the system to work with. Here we were using the graphical user interface, but of course that could all be done as well by calling services on the framework. For example, to upload such a topology description to the CMDB would be possible.